Hi students, good evening. This is Sumit Kundu here. I'm a BTech graduate from IIT Bombay, and today students will be taking up a session on solving questions, all right, from laws of motion. Okay, so students, let me give you a brief overview. Okay, laws of motion, definitely a very important chapter from the JEE point of view. Okay, both from mains as well as from the advanced point of view. I mean, it is like the backbone, as you would say, of physics. All right. And yes, it could be a little tricky for some students. All right. However, the most important thing, students out here, is that in this particular topic of laws of motion, all right, if we can save lot of time basically doing these problems. Clear? So if we can save a lot of time, my dear students, we have time for other important questions. Let's say deal with electrostatics or magnetism or anything of that sort. Okay. So specifically, I've taken up one section of laws of motion. Now, laws of motion as such is very, very vast. Okay. So what I've done is I've taken up a smaller section. Okay. And that is with respect to your pulleys. So guys, do you love pulleys? Yes, you do. Okay. Now, here are all the questions that I'll be taking up is going to be dealing with pulleys, right? I am assuming that all of you know the basics of laws of motion, right? How to draw the free body diagram, which are the forces, what is tension force, what is normal reaction force. Though in case of pulleys, we are not going to see many normal reaction out here. But yes, tension force you should be very, very clear about. Okay. With respect to tension force, I would not like to spend more time on that. Okay. Only one thing, tension force for your information is always pulling in nature. Okay. And normal reaction force is always pushing in nature. Right, students? So here only with just that much idea, we are going to start off with today's session. Okay, I'm going to take up a very simple problem first, and then we look at different scenarios where we can actually look at saving time. Clear? So the first one, that's very simple, isn't it? Okay, so what do we have here? We have got a very simple pulley arrangement, one mass M1 out here, and the other mass M2. Clear? Students will take up a very simple one and then we'll go on advancing till we do constraint relations. Then instead of a string, let's say we will be putting across a spring in case of a string, and then we are going to see what is going to be the acceleration. Okay. Now here, very simple one. We know there's going to be tension in this string and there is going to be tension out here. So students, what is the tension out here? Let's say it is T. And the tension out here is also T. Clear? Now, here, students, if I have to solve it, the first thing that I'm going to tell you about for any questions in laws of motion, it is very important to define the coordinate system. So here, my dear bacha log, this is my positive y and this is my negative y. Halaki, in this case, the x coordinate is not important, but we'll still define it. It is like plus x and this is like minus x. Okay, students, if I have to draw the free body diagram out here, okay, now you'll be saying like, so what's the shortcut out here? We're doing it by the long cut method. Okay, fine. We will use the long cut method for once. Okay. Students, then what do we see here? What are the forces going to be acting here? Let's see. Downwards. Yes, which force is acting? M1 G. Very good. And here too, there is going to be another force acting here. So that is going to be your M2 G. Very good. Then, what do we write? We write down the force equation. The force equation is going to be like, for the first one, I'm going to take M1 and T is in the upward direction, so it's positive because it is plus Y is the positive direction, so T minus M1G is going to be, for all purposes, we are going to assume that my M1 is greater than M2. Then definitely, my dear students, this M1 is going to go down, let's say with an acceleration of A, and this M2 is going to go up with an acceleration of A. Whatever is the acceleration of M1 in the downward direction is the acceleration of M2 in the upward direction. Okay, so T minus M1G for this particular mass is going to be now minus M1A. Why minus? Because it has an acceleration in the downward direction. So downward direction is negative, my dear students. So that's my first equation. Then I'll take this. Then I'll write down the force equation for my second mass. What is it? T minus M2G is equal to plus M2A. Why plus? Because it is going in the upward direction. So that's like upward. Clear? Now here, my dear students, what we are going to do is we're going to solve this. What we can do is we'll multiply this entire equation with minus 1. So this becomes like minus, this becomes plus, and this becomes plus. And then do one thing, add up both the equations. So you get like your tensions cancelled off, and you will get like M1 minus M2 into G is equal to acceleration times M1 plus M2. Clear, guys? Then what is going to be the acceleration out here? It is going to be M1 minus M2 divided by M1 plus M2 entire thing into G. So that is, students, my acceleration of both the blocks for M1 going down, for M2 coming up. Okay. Now, students, if I were to solve this, if I tell you that any given situation of one pulley, basically, and you can find out the acceleration without going through so much of effort. Just one formula, the basic formula, just remember this. Okay? And I'm going to extend it to other scenarios. How exactly? Let's have a look. So let's take this one. Okay? Students, in the previous problem, what did you get? Acceleration was equal to M1 minus M2 divided by M1 plus M2 into G. Clear, guys? So here in this particular scenario, here this is theta1 and this is theta2. What do you think is going to be the acceleration out here? So the acceleration, students, is going to be, for both the blocks, it is going to be the same. So it is going to be M1 theta1. So put it as sine theta1 minus M2 into sine theta2, all right, divided by M1 plus M2. M1 plus M2 into G. So students, this is the more general format of the equation. Okay, and let me tell you, using this you would be able to deal with a lot of variety of problems in which you've got a pulley and there's a mass on one side and there's mass on the other side. Okay, now here let me take up the second one, and we are going to apply this special formula that we see here. Okay, students, so what did we see? What was the special formula? A is equals to M1, okay, sine theta1 minus M2 sine theta2, clear, divided by M1 plus M2, clear, whole thing multiplied by G. Okay, just students, remember in this one what we will do is let's assume that my M2 is greater than M1 for this. say M2 is greater than M1. However, even if M1 is greater than M2, probably there is no friction, it is going to move, undoubtedly. Okay, now the main thing is, what is going to be the value of theta1 out here, students? What do you think is the value of theta1? Theta1, what do you say? It is 0 degrees. Theta1 is equal to 0 degrees, okay? And theta2 out here, students, what is going to the value of theta2? Theta2 is nothing but equals to 90 degrees, okay? Then in that case scenario, my acceleration, assuming m2 is going to be greater than m1, so here m2 sine theta 2 minus m1 sine theta 1, it should have been. So students, what is going to be the value of the acceleration? Yes, you got it right. Okay, it is going to be just m2 divided by m1 plus m2 into g. Can you imagine, so much of time has been saved doing this particular, just knowing this particular formula? We see all of these special cases time and again in the Newton's law problems. Okay, so guess here, what is the value of my theta1 and theta2? Theta1 is equal to 90 degrees. Say we will take m1 greater than m2 out here, no problem with that. So theta1 is 90, and what about theta2? Theta2 is also 90 degrees. My dear students, then what is going to be the acceleration? The acceleration is going to be m1 sine theta 1. Sine theta 1 is sine 90, that's 1, minus m2 sine theta 2. M2 sine theta 2 is simply m2, my dear students, divided by m1 plus m2. That is so much equal to what we have for a very, very simple pulley. The same result. Okay, and let's just look at one more, and then we can proceed ahead to the constraint motions. Okay, now here in this case, my dear students, my theta1 is theta, and theta2 is equal to 90 degrees. Clear? Then the equation for acceleration is going to be how much? m1 sine theta 1 minus m2 divided by, that line looks pretty awful. Let me get a better one. Okay, so here in the denominator, life stays still the same, m1 plus m2, and all of it multiplied by g, my dear students. So I think you can well master if you have got this kind of a situation or this kind of a scenario existing in the question. Without taking much time, students, you should be able to find out the acceleration. And once you get the acceleration, it doesn't take actually much time to find out the tension, my dear students. Okay, so what we will do is, since we have got very less time out here, it's a modular course, my dear students, wherein it's a 2-hour course basically. So while we do the modular course, I'll teach you how to find out the tension forces also very, very quickly without any calculation actually. All right. So that is going to be all there in our modular course. All right. Now here, students, now there I kind of move to, I'll just introduce one slide out here and say we're going to begin our constrained motion. Constraint, S-T-R-A-I-N-E-D. Okay. Now, sometimes these spell check softwares have spoiled our habits. Constrained motion in pulleys. Clear? What do we mean by constrained motion, by the way, students? That is, motion of one part is linked to the motion of the other part. Nothing is independent. They are all dependent on each other. Even in case of like, a very simple arrangement, just like this pulley, it is a constraint motion. This moves, this goes up. So the motion of this is actually determined by the motion of this. So it goes down, it goes up. Is this clear, students? So that is what is my constraint relation is. Okay. Now here, students, we have got multiple ways of doing these questions. Okay. One such technique is that, like, by finding out, like, the total length of the string, all right, and we kind of say if block A moves by a distance x, all right, then what is going to be the distance moved by block B, and then we differentiate it once with respect to time, we get a relation between their velocities, then we differentiate twice, we get the relation between their accelerations. And students, what we do is, like, the basic concept we use is dl by dt is equal to 0. All right. Now, sometimes it creates a little bit of an ambiguity in the minds of the students. All right. While using dl by dt and finding out the length, okay, imagining if this moves by x, how much should be the other moving as? It creates a little bit of a confusion. So we have got a better method out here. All right. What is that better method? The better method is sum of the work done by the tension force is actually equal to 0. All right, sum of the work done by the internal forces is 0. That actually we kind of study in our work energy theorem. All right, if we have internal forces, we kind of neglect them. Is actually, like, no effect in the kinetic and change in the kinetic energy due to the internal forces. Clear, students? So here we are going to use that principle, clear, in order to get the relation between the accelerations of the different blocks. Okay, I just, students, remember when I did in my first problem, can you note one thing that I have, in a way, taken the acceleration of both the blocks to be the same. All right, but this is easy to figure it out here. So that is my that is my third equation that we have out here. Okay. Practically, if we don't know that what is the relation between the acceleration of both these blocks, probably this simple sum would have not been able to be solved. Okay. So through this constraint relations, we try to figure out the relation between the accelerations of, now in this case, for M1 and M2. Now here, students, we got this. What we can do is we can differentiate this equation once with respect to time, obviously, and we will get summation of T dot V is equal to 0. All right, so that's kind of important. Next, you differentiate this once more with respect to time. What will you get? Summation of T dot A is equal to 0, my dear students. Okay. So in a way, I have got my life sorted out once I try using this. Let us look at the magic of this formula, of these formulas. Let's see. Okay. Chalo. We'll start with a very simple one. So they're talking about in terms of velocities. They have said that this block out here is having a velocity of 2 meters per second, clear, in the downward direction. In the downward direction. They have asked us to find out the velocity of this block. Clear? Very simple. So let us say the velocity of this block in the upward direction is some v2. Clear? We're going to use the relation summation of T dot V is equal to, my dear students, 0. All right. Then first thing that I'm going to do is find out the tension distribution in the strings. That is the most important part of this questions. So let's say the tension out here is T, my dear students, it's all ideal scenario. In case of ideal scenario, your strings are massless, they are inextensible, the pulleys are massless, and being massless, the pulleys, and they're frictionless, the tension on both sides are going to be equal. So this side also, it's tension T, and here also it is tension T. Okay, then students, what is going to be the tension out here? Let's say this is like T dash, and then if I take this section of the pulley, all right, students, and try to analyze this part out here. What do I see? I've got a pulley out here, and there are tension forces. Oh, spot tension. There are tension forces out here. Clear? All right. Aha. And tension out here. I've just told you in the very beginning, tension is always pulling in nature. So you've got a T here, you've got a T here, and I've got a T dash out here. So that's like T, this is like T. So my dear students, if I write down the equation 2T minus T dash, all right, minus T dash is equals to mass of the pulley into its acceleration. So whatever would be the acceleration of M1 is going to be the acceleration of this particular pulley. But students, we are considering an ideal scenario. Ideal scenario means mass of the pulley is equal to 0. Then what do I get my T dash as? Then my T dash becomes equals to 2T. Clear, students? So this finding out the tension is the most important part, and after that applying the equation is very simple, students. Okay, so what do we see here? Tension T dash is in the upward direction, velocity is in the downward direction. Students, what is the angle between the tension and the velocity? 180 degrees. Okay, and students, what is cos of 180 degree? Cos of 180 degree we know is equal to -1. Very good. Okay, so cos of 180 degree is -1. Okay, so what I'll get? Minus T dash, which is nothing but equals to 2T, we have just seen. So it is 2T into how much? 2 meters per second plus. What is the tension in the string out here? T. What is the velocity? V2. All that should be equals to 0. So we are finally taking this T dot V for all the blocks which are connected in the system. Right, students? So what do we get the value of V2? T common, it goes out. So V2 is nothing but equals to 4 meters per second. Get that? Simple one. Okay. So students, we will be using this for a number of problems right now, and we'll be looking at the relation between velocities, displacements, and accelerations of the various blocks which are connected in a pulley system, right? So at least make one part very simple. My pulley system should be a cakewalk after this session, okay? All right, here we have another one. So what is the first thing that you do? Step number one. Step number one. Find the tension in all the strings. Find the tension in all the strings. Clear? So now we are kind of defining the steps. Clear, students? So here take it as T. Here also it is going to be T, my dear students. All right. Acha, students, if I take this as T and this is T, how much should this be? These tensions? T by 2 and T by 2. Just by the same logic, if we kind of take this part of the pulley. All right, students. So if we kind of take this part of the pulley, then we will look at it. That T by 2 should add up to T. All right. First part of my job is done. Achha. You should not be confused. It's not any mass out here. So let me just remove that confusion by drawing it in this way. Okay. So I think that part is very much clear. The second thing, step number two. Step two, apply summation of t dot a. Clear equals to 0. I think that's a simple step. Okay, so we're going to do it for this one. It's going down, and tension here is in the upward direction. What is the angle between the tension and the acceleration? 180 degree. Cos of 180 degree minus 1. Very good, my dear students. So that is like 3t tension into acceleration. And for this block, acceleration is going to be in this direction and tension is also in the same direction. So the angle between tension and acceleration is 0 degree. Cos of 0 degree is plus 1. So it becomes like plus t by 2 into acceleration of block A. My dear students, all that is 0. Okay, then what do we see out here? 3 is equals to acceleration of A divided by 2, which implies the acceleration of A is equals to 6 meters per second square. Okay, fine students. So I think you've got that comfort zone in these kind of questions now. Okay, so we'll kind of move ahead. We'll look at few similar problems, all right, and then we'll kind of move to another genre. How about this one? I think this one is also very simple. If you look at it, though it looks like a little complicated out here, okay. However, I think first step, find out the tension quickly. Let's say this is T, so this is like T. By the same logic, this is going to be like 2T, my dear students. This also is going to be 2T, 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 4T. All right, same here, 4T. And here in this one, it is going to be 8T. And same here, that is your 8T. I think it's very simple now. What do you do next? Okay. The simple thing that you do out here is 8T, and it is in the upward direction velocity. We apply summation of T dot V is equal to 0, my dear friends. Okay, so for this block out here, we say it is 8T into V1. All right, assume this is going down, tension minus T into VB. All right, so that is all equal to what? 0, my dear friends. Okay, so if I have to find out VB, VB is going to be 8 times V1. All right, just another demonstration of the usage of, let's say, the shortcut method to find out the constraint relations. Okay. Actually, now students, this question had appeared in JEE Advanced a few years back. All right, under the objective section. All right, you had multiple choices out here. So the question that is being asked out here in this question, in this problem out here, you can easily see the arrangement. This is being pulled down with a velocity v, and this is also pulled down with a velocity v. Okay. Now, as they are being pulled down with velocities v, they are asking us what is going to be the velocity of block M. Students, we know that it is going to go up, right? So let's say the velocity of this block is v1. Okay. Actually, students, another thing now, that's step number 2. We are going to take the component of this velocities along the string, because the tension out here is along the string, right? So we take down this particular thing. So the tension out here, if let's say is T, here also it is going to be T, here also it is T, and here also it is T, my dear students. Fine. Now what do we do out here? Very simple. tension for this part is in the upward direction, so minus TV. For this part also minus TV. All right. Now here in this case, as it is going up, the tension component along this direction is V1 cos theta. And here also it is V1 cos theta. Clear, guys? Then I can say it is plus 2t V1 cos theta is equal to 0, my dear students. Okay, then I think now it's very simple. The tension all goes away, the tension burns away if you do it this methodology. So it is nothing but V is equal to V1 cos theta. Then they have just asked us what is going to be your V1. V1 is nothing but V divided by cos theta. Okay, students. So that is the answer, and very simply you could have scored. It was assigned some 4 marks for this problem out here. Okay, so easily just by knowing the shortcut method, and you save so much of time doing that particular thing. Okay, the next one, I think this is one very good problem that we can take up. Looks a little complicated, but it's kind of very simple. Let's just have a quick look at it. See, the first thing what we do, tension here. Here also, it is going to be the same, TT. This is going to be again T. This is going to be T. So how much is this going to be, my dear students? T by 2. And this also T by 2. Clear? Overall, here it is going to be like 2T, and here it is already T. Right, students? So once we know the distribution of the tension, again, all tension is taken care of. Okay, so here with respect to this block, it becomes like minus T by 2 into 12, because they are in opposite directions. They have asked us the acceleration of A, plus what is the total tension acting out here, my dear students? It is 3T into acceleration of A is equal to 0. Clear? Then overall, what will this become? Equal to 2 6 times, which implies my 3 acceleration of A is equal to 6, which implies the acceleration of A will be equal to 2 meters per second square. Okay, students. So I think we have got enough practice of these kind of problems in today's session. Okay. While I was trying to get ahead and look at this problem here, well, there is a spring connected out here, and how we deal with this, students, what I see is I'm kind of running late now. Okay, the time's already up for these problems out here, for this session today out here. Okay, so what we'll do is in the modular course, we are going to look at similar kind of problems out here, the ones with this spring. Okay, and as I promised you, we are also going to look at how to calculate the tension in all these cases. We have found out the acceleration, so we'll just quickly go ahead and in our modular course, look at how to find out the tension, and I'm going to do more on these spring-based problems in the pulley. Okay, so it's like I can have I can extend this to so many different cases. I can have a spring here, and I can attach another particular block, say that's like my block C, and then I can compare the acceleration of all these blocks out here. Okay, and students, what we will also do, we are going to do the constraint relation of blocks in my modular course. I'm also going to do constraint relations of blocks. Clear, students? So that is going to be very much the agenda. I think that is one of the very much of a pain area for all the students that we have identified over the years, and this is what is going to be the focus of the modular course, my dear students. Okay, so in order to register for the modular course, click on the link below. Okay, and see you soon for the session on laws of motion where you can interact, you can ask as many questions, okay, and then we can kind of look at getting that done for you guys. Okay, take care, guys. I hope you liked today's session, and if you do like today's session, click on the links and register for the course, and let's meet up very soon in a modular course on laws of motion. Thank you very much, students. God bless you all, and good night to all of you.